during the preparation. While I can be present here, I want to point out that I'm a mathematician and not a programmer. It is important to me to name Bernd Busse, who cannot be here. He is the main developer at our team and had a great part in preparing this talk, as well as the preprint that is in the booklet. We both work at University of the Federal Armed Forces, which in German is called Bundeswehr, at Munich. Then this here, .com, stands for Data Protection and Compliance, which is our professorship at the Research Institute Code, which itself belongs to the Department of Computer Science there. I cite from the website, the Research Institute Code is a central scientific research facility of the University of the Bundeswehr Munich and uses its expertise to create innovation in the field of cyber IT for the Bundeswehr. We conduct both basic and application-oriented research and technology development in the fields of cyber defense, smart data, and quantum technology for the benefit of society and, of course, the Bundeswehr. Having said this, let's move on to CrypTool. Okay. If you look at this table of content, you will find that I mostly will follow the preprint, but I chose to also talk about two of our sub-projects, namely the CrypTool-Buch and historical cryptography. This I decided because I think that those would be interesting for this audience. Okay. The QR code leads you to our landing page. See the screenshot on the right. You can start to explore our sub-projects if you click on the icons on the left here. Depending on your device, the icons could be hidden in a burger menu on the top left. I will not go through all of them. The green one on top, the O, stands for CrypTool Online. This is where we use KaTeX, on which I will focus on later. Here you have an overview of our sub-projects. As the name already suggests, we offer tools for cryptography. They are free of cost and advertising, and we do not collect personal data. We were fully open source once, but not anymore because unfriendly actors copied our whole webpage, flooded it with ads, and we had to deal with angry messages from all our user base over the world. So we stopped this. But feel free to send us an email and we give you access to our private GitHub repository if you want to do research or otherwise want to contribute to the project or are just interested in the code. We are really open to do that. Our work splits into maintenance of existing software and development of new products. In the last years, we focused mainly on mobile-friendly, responsive online web apps. Let's begin with the CrypTool-Buch, which of course was written in LaTeX. The CrypTool-Buch was my personal entry point to the CrypTool project. I got to know the author, Bernhard Esslinger, at a Dante meeting. I overworked quite old sources, which came from different authors, partly from the 90s. They used outdated packages and stuff, so it was a lot of work to bring this kind of up to date. There were many listings that had to be customized, and I will go into this in the next slide. Here you have an overview. You can also find this project on the main page. If you go to the CrypTool-Buch on the main page of our project and you scroll down, you will see that every green line is some additional free material. We wanted to keep offering open access to as much as possible. So you can find a lot of linked material here. For example, we have an introduction into the command line interface of OpenSSL. We also have an online app built with WebAssembly where you can apply OpenSSL. It's quite liked. And we also have a SageMath intro. I, as a mathematician, enjoyed very much testing and typesetting all the SageMath scripts. There are 140 of them, and you can download them here. We have a free access chapter on historical cryptography or cryptology written by the members of the Decrypt project. I will give a link later. This screenshot shows the SageMath code of the Caesar cipher in the CrypTool-Buch. The German version is on the left, the English version on the right. Since Artech House, the publisher, wanted to reduce pages, the code on the right side is missing the comment. We included as comments the output that should occur on your terminal for every script in the German version. From a tech point of view, those listing environments were quite some challenge for me, especially to not let them float and get automatic page breaks like this here with an appropriate continued text. My experience as a LaTeX user around 2020 when I did this was often that different packages interfered quite a lot. So I had to study. This author had used this package in 1915 and then, or 2015. And then, okay, now there is a new package and the new package is better. And then I tried out the new package, but the new package does interfere with another package and so on. So I had to read a lot about packages. Okay. Now to historical cryptography. I added some slides about this because I think it's interesting for typography. By the way, cryptology is the right term, but most people say cryptography. The latter, however, does not include cryptanalysis, but focuses on how and why cryptographic procedures work and not how they can be attacked. If you go to the website of the Decrypt project, you will e.g. also find a database of historical manuscripts, which was built by this group. And you also can find there the lost letters of Mary Stuart. Perhaps some of you heard about those letters. The CrypTool project maintains CTTS, the CrypTool transcriber and solver, which was developed by George Lasry for deciphering those letters. It facilitates the manual transcription of historical encrypted texts into digital, machine, and human-readable format. It has many cryptanalysis features, e.g. a graphical interface for symbol segmentation. Mary Stuart used so-called homophonic substitution. On the bottom right of the slide, I included some helpful links for getting you started. For example, the famous Zodiac Killer cipher is also a homophonic one, and you can try to solve it with one of our apps. Now let's get to some website statistics. We use Umami because it's general data protection regulation compliant. Yeah, could you play the first video, please? You have to click on the picture, and then it should open. Okay, good. As you can see, we have about 1K visitors per day. We can switch to the last 7 days and identify the weekends, which was 5th and 6th July. This is a pre-recorded video. There is not so much going on. You can scroll down and see the most popular subpages, like OpenSSL or also step-by-step. And you can see how our visitors found us, mostly Google, but also ChatGPT. Then you can see the used browsers and OSs. And we can also see the visitors' countries, e.g. India occupies the 3rd place. Thank you. We can go back to the slide now. Okay. So, of course, Umami is free and open source. Now let's switch to mathematical typesetting in the browser. There are 3 common ways to generate mathematical typesetting in the browser, which are MathTeX, KaTeX, and MathML. MathML, we already heard today a lot of it, is an XML dialect, and it describes math in angle brackets. Syntax, it's a subset of HTML5. Here is a minimal example of the Pythagoras theorem that I generated by ChatGPT, and here you have a list of elements. For example, we already saw today the MI, which is like here for the B. MathML apparently has not fully caught on in web development pages because it was kept too general and therefore was never implemented consistently. With MathML Core, this is supposed to improve. Now to the other 2 technologies for typesetting math in the browser, which is KaTeX and MathTeX. Both KaTeX and MathTeX are based on JavaScript. You can see that MathTeX is written in TypeScript. TypeScript is basically just JavaScript with a transpiler for pre-processing. E.g., JavaScript lacks static type checking. MathTeX supports more LaTeX commands, but we don't need the very complex LaTeX features in CrypTool. KaTeX is faster, and that is the main reason why we use it in the project. I included a time comparison link on this slide, but we will not try it out because of time constraints of this talk. You can click on it later and try it. The GitHub commits over time perhaps do not really indicate much because we do not know how large those commits are. But anyway, you can see more recent activity in the KaTeX group. Now to the command line interface. If we call the KaTeX via the command line interface, we can generate HTML files for in-browser rendering. I have a video, perhaps the video 2, click on it. Always click on the image. Just click on the image. Yes. Thanks. Okay. So I generate a KaTeX environment. I changed there, and as you see, it's empty. Then the node package manager is initialized. And now you have a JSON file here. Then I install KaTeX. Could it be that we do not see the whole video? Yes, thanks. Now KaTeX is installed. We have a distribution. We open this file. It's the entry point. for the console. It just has about 250 lines. So this is not the real KaTeX. When we go to the distribution folder, there is also a KaTeX JavaScript, and if we open this, this is the real file, which also has a lot of lines, as you see. And then there is a minimized version, which has no white spaces and renamed all the variables to be shorter, because then for being transferred through the web, it's better. Okay. You also have a source file, because perhaps you want to compile all of this by yourself, and then you can generate your distribution, but it's pre-compiled. Thank you. And then the next video shows how you use the command line interface. You call npx KaTeX. And then there is no prompt, which perhaps is a little bit confusing. You just type your formula and then Control D, and this is what comes to the standard output. You can pipe it into a file, which I call here Python HTML. Do the same, but then it's saved to a file. And when you open it, you see it's the same 2 lines. Then you can open this with a browser. And this is MathML. It's a fallback for accessibility, and this is the KaTeX output, but without any CSS. So it's not typeset as we want it. This is the same file I just showed in the VI. So what I do next is I copy this file and add the loading of the CSS file, which then renders the KaTeX. Then I again open this. And now you have to be fast. When I compare the 2 files, look at the letter B. So this is the new one. The MathML accessibility fallback is missing now, and it's rendered like it should be. And here you have this from before. And this is how it should look like with CSS. The first was without. Okay, thank you. So this is how I can use the command line. It's quite good documented. It's not so hard. Before going to how we use it, because we do not use inside browser rendering, I give a short introduction about our technologies of our web project. I will not go into all of those because it would take too long. You can read it up in the preprint. Let me just mention that our apps are built from so-called React components. React is a JavaScript library developed and maintained by Meta since 2011, and it was open sourced in 2013. Here is our technology. This is a part of our documentation on GitHub. We have quite well documented everything because we have often we have students programming little apps and they have to read up this stuff. Later I will show one of those components. Okay. Also here I will not go into detail. In short, we use pre-styled components from, again, a library which is called Chakra UI, and some of our own custom written components. E.g., our KaTeX component, I will show a video later, is a custom written component. The full code is included in the preprint. You can find it in the conference booklet if you are interested. Now, how we use KaTeX. When we search for KaTeX in our GitHub repository, there are only 4 matching files. But when we build the website locally as a developer or also on our server, of course, then there are more, like this listing shows, quite a bunch. You can just, it's similar to what I already showed, you can install it. First you have to download it from our GitHub repo and so on. And then we have a webpack which extracts every necessary rules and then optimizes it, concatenates it into a single bundle, which then can be transferred through the web fast. We will now show 2 videos. The first one goes through our example component, shown in listing 6 in the preprint. Yes, okay. Now here on the left, you have the code, and on the right, the output. Here we import our KaTeX component. And also this is a little helper we wrote for being able to write escape sequences like that. Also this is one of our own written component. Then we can define a formula as a constant, which is this one. We can use expressions with a $sign, which is not a LaTeX dollar, but a template expression. And then this gets evaluated to 2. As you can see here, this 2 comes from this. Then we use our TeX component, which produces now this. Or we can use a block environment. The string then is rendered directly with a display look. We also can hand over the aligned. And then you get this aligned formula. Or we can change it to just align, and then as you can see, we have numbering now. So it adapts. Additionally, we can specify styling parameters that are used for Chakra UI, like this here. The white space no wrap makes that it doesn't break into a new line, which it would otherwise do because of the narrow width. If we left that out, as you can see, it would wrap. Thanks. Now the video should be finished. Okay. So this was an example, and now please play the next video. This shows the component KaTeX. In line 6, we see the import of the KaTeX from the distribution. Our actual component is located further down, starting at line 64. It receives several parameters, some of which we've just seen. For example, children and math are important for the actual content, and with block we can pass the parameters for the environment. Now let's move up again. Here we have use environment. Basically all it does is wrap a begin and end environment around the string if we want to use such a display math environment. If that's not the case, we'll simply return the content. Now in line 80, with this content, we can now continue working and use the use KaTeX function. This function is also custom written and is located further up. Let's briefly look at it too. Here the actual KaTeX render to string is called. We see that the text string and the options are passed as parameters, and returned is the HTML string. If an error occurs, we generate an error message. The result in line 80, we now finally can write into the web page in React, line 98, using dangerously set inner HTML, even if it's statically rendered. We are only working with static content here. What we see above in line 92 are things for error handling so that we can display errors. Finally, if we move up again to line 13, it's important to see that we import the CSS at the top. That means whenever we use this component, the associated CSS is also loaded. Okay, thank you. You can close the video. Okay. Now, again, I will show some code of the component RSA. If you want to look it up in CrypTool online, RSA Step by Step is a web app where you can try out this cryptographic procedure. It's quite famous. Okay. Wait. Yeah, okay. KaTeX in CTO also comes up inside of Markdown, and we use Markdown here if we have text in our apps. One of our smaller apps, RSA Step by Step, is available here, as already said. And we will now watch a video again, which shows how those interact. So this is a file. Here you can see the content on the left, which is written in Markdown. Here we import our KaTeX component. You can already see in the first paragraph in line 20 how we use it with Markdown. For instance, here the P and Q, they occur here. When we go to step 1, here, the P is rendered using our Artech component. If we further scroll down, we see that the values for P and Q are substituted by those that are currently inside the input field here. And if we change it, you can see that it instantly adapts. Now to step 2.1. Here is the corresponding code block. What happens here is that we have this encryption exponent 17. And from a medical point of view, it has to be co-prime to the Euler function of the so-called RSA modulus n. And so we have to ensure that the user gets some warning if he chooses the wrong E. And this is implemented here. Okay, Thank you. So I'm nearly done. This is my last slide. At the moment, we only use the default fonts, but we would prefer to switch to sans serif math because the other fonts are also in sans serif. The screenshot shows what's there in KaTeX at the moment. Sans serif, that's all. I included some links. I won't go into it. But if somebody is an expert in this and wants to help, any help would be appreciated because this would be the next little project to change the fonts. Okay, so thank you. If there are questions. Also, our web developer perhaps is online. If there are questions that I can't answer, perhaps there will.
Okay, so I wanted to ask about the fonts. Which fonts are you currently using? As in, you mentioned that you want to switch to sans serif. So, which are the ones you are currently using for text?
Just the default fonts. I guess it's the Roman fonts.
Default
the
of
default,
LaTeX.
the default.
Defaults of LaTeX?
Yes.
Okay, so, sorry?
Web fonts. Yeah. 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 Yeah.
I'm only saying you are speaking about web fonts, not about LaTeX fonts. So we can't tell you from the LaTeX side or TeX side what fonts you should use. You need web font.
So it will. So you mean it will choose the fonts from the user's system?
No. There is a web page on KaTeX, and they deliver those fonts. On the last slide, I put those links. You can look them up.
Okay. So
the KaTeX has a GitHub page, and there they have a list of the fonts that they use.
Okay. Are they? Okay. Anyway, I just wanted to mention that for sans serif math, there is a recent development in the new computer modern family, and they have a sans serif font now, which matches the Latin modern sans design. So you may check that out. That's the only thing I wanted to mention.
Thanks. Yeah? Yeah? No, we are using serif and we would like to switch to sans serif.
Just wanted to clarify for people who may not be familiar with KaTeX. KaTeX uses the TeX mechanism in JavaScript, so it's a transpiler kind of. So uses EFM font metrics. So if you want to replace it by, you have to recompile KaTeX using the new set of fonts so that all the metrics. So it's almost KaTeX kind of mimics the LaTeX compiling process completely in JavaScript. So you have to understand the font mechanism in LaTeX to do the whole thing. So you have to start with the font metrics. You have to create, see if you have a new true type font or whatever, you have to create font metrics, then recompile the KaTeX, and then it.
Yeah.
I think right now it uses computer modern, so that's the default.
Thanks.
Any more questions?
Are you planning to also implement other LaTeX-oriented stuff in KaTeX, or is it
No,
only
because we
math?
just are using KaTeX. We are not developing KaTeX.
Oh,
Yeah.
I'm sorry.
So-
Okay.
We are just implementing KaTeX to use it with our apps.
More questions? Thank you, Doris.
Okay, thank you.